The next problem I'd like to look at is this line integral. So I want the integral along c of the square root of x squared plus y squared. That's what z equal. R of t is given right there. This is for the cosine of t, for the sine of t, and 3t. Well, I know what I need. To find ds, I need to find the magnitude of v of t, which is r prime. That's negative for the sine of t, for the cosine of t, and a 3. So the magnitude of r prime of t is going to be the square root of negative 4 sine of t squared. That's basically the magnitude of this, plus for the cosine of t squared plus 3 squared. That's the square root of 16 the sine squared of t plus 16 the cosine squared of t plus 9. That is the square root. If I factor a 16 out, and I know sine squared plus cosine squared equal 1, so this is the square root of 16 plus 9, which is square root of 25, 5. So this is going to equal the integral of the square root of, and x is given by, and y is given by, so that is 4 the cosine of t squared plus 4 times the sine of t squared, and this ds I'm going to replace by the square root of 5 and a dt, and I'm going to integrate from negative 2 pi to 2 pi. I still need to work this piece out. This is actually 16 the cosine, cosine squared of t plus 16 the sine squared of t. So this is 16 into cosine squared plus sine squared, which is 1. That turns out to be a 4. That turns out to be, I wrote a radical 5. Look, with all the excitement what happens. You guys don't get excited. And I'm going to integrate that from negative 2 pi to 2 pi. Again, don't get excited. And wouldn't that be simply 20 times t, 20 times 4 pi, which is 80 pi. Now, what do you do with that? Well, I'm glad you asked. Just give me a couple of lectures, and believe me, any question you have will be answered. We're going to leave no stone unturned. You're going to look under everything and figure everything out. Just give me time. 14 is the same. We want to figure out the integral along c of f of x, y, z, ds. Well, guess what? This is the integral from 1 to infinity. Section 4.5, L'Hopital. We dealt with this stuff, right? Times, how does that work? My function is radical 3 over x squared, and r of t is t. So that is t squared plus t squared plus t squared. To find ds, I'm going to have to take r prime of t, which is 1, 1, 1. And ds is the magnitude. I'm going to keep on writing that in until you get sick of it. Yeah, and I'm not going to stop. That is 1 squared plus 1 squared plus 1 squared, which is radical 3. So this ds is actually radical 3 dt. And that's going to equal the integral of 3 over 3t squared dt, right? That's going to be, you know what, let me write it slightly different so you could follow it easier. I'm going to put this down here. And now with an arrow, you could follow easily. That's going to be the integral of, so what is that, t to the negative 2. So that's going to be t to the negative 1 over 1. So that is negative 1 over t, if I'm not mistaken, evaluated from 1 to t. From 1 to, we can't use t anymore, let's say b, and taking the limit as b approaches infinity. And what would that be? That would be the limit as b approaches infinity of negative 1 over b plus 1 over 1. This will hit 0, that will equal a 1, and there it is. And just so that you would know, anytime you're looking at t approaches infinity, all what that means, if you let this system run forever, indefinitely, what's going to happen on the long run? Is it going to level off? Is it going to break? Is it going to divert? You know, all of these awesome things. Here's another problem. It says integrate this function f of x, y, 0, x plus radical y minus z from 0, 0, 0, from the origin to 1, 1, 1. Path 1 is simply 0, 0, t, and t varies between 0 and 1, and you could see how path 1 runs. Right there, from 0 all the way to 1, and it's running upwards. Now, if I go to the second, this is I, j, k. So this is fixed at x equals 0, z equal 1, and then y varies, or the j varies, from 0 to 1 in that direction. And the third is actually t, 1, 1. So we're fixed at 1 and 1 right there, right? Z equal 1, y, z equal 1 and y equal 1. But the I varies from 0 to 1, creating distance. So, if I want to really figure out the line integral along C2 and C3, that's really what this integral equal. If I look at the integral all along of f of x, y, z along C of ds, that's going to be the integral along C1 plus the integral along C2 plus the integral along C3. You're going to add those. So I take the integral along C1 of f of x, y, z ds, and that is the integral from along C1. Let me color code this. Let's go with blue. Right? Remember, you're going to throw this in that function. That's going to be 0 plus 0 minus t squared times r prime. If this is r of t right there, if I take r prime, that is 0, 0, 1. And here it is 0, 1, 0. And here it is 1, 0, 0. So either way, it's always going to be radical 1 dt. In this case, you're going to integrate from 0 to 1. Plus, along C2, you're going to still run from 0 to 1. That's not going to change. Oh, I switch colors. That's okay. And here, if you plug those in, you're going to get 0 plus radical t minus 1 squared dt. And along the third, it's going to be the integral from 0 to 1 again. And if I take those and substitute those in, I will get a t plus 1 minus 1 dt. And I'm assuming you can integrate that with ease. The hard part is setting this up, or in the beginning, figuring out what they're doing. Same deal with number 22. If I get to number 22, well, let's see how that works. They want to figure out what the integral is along C of the square root of x. And we know the drill by now. Hopefully, you're getting really used to this. That's x, and guess what? That's y. So that's going to be t, and that's going to be twice 4t. And what am I going to replace the s with? Again, I'm going to say, well, let's r of t, that's going to be t 4t. And since I'm letting x equal the t, guess what? I figure out that t varies between 0 and 1. And what is ds? I need r prime of t, that is 1, 4. And ds is simply the magnitude of r prime of t, that's the square root of 1 plus 16, radical 17, if I'm not mistaken. And there it is. That's going to be the integral. Radical 17 is a constant from 0 to 1. And this is going to be the square root of 8, 9t dt, right? And this is radical 17 times 3. The integral from 0 to 1, t to the 1/2 dt. And I assume you could finish that up. I'm going to do a lot of that. I'm going to try to set up all the evens if I can. This chapter is a bit annoying. And anything you can integrate in the notes, let me know. I'll be more than happy to work it out for you in class. And 22, the same deal, except here they give us the limit. So that's the integral along C of f of x, y, ds. You could just say f if you really want. That doesn't really matter. That's the integral from 0 to 2 pi. And let's see. We are going to take, remember how this plays. We are going to take this and this. You know what? I should use different colors. That will help. So, as for x minus as for y, and there's a plus 3. And that's this. So, this is the cosine of t. This is the sine of t plus 3. And ds. Never going to get old. I take r prime of t, and there's r. They gave us r. That would be negative sine of t cosine of t. And this is going to happen a lot. If I find ds, that is the magnitude of that vector. That's the square root of sine square root of t plus cosine, plus cosine square root of t. And that's nothing than 1 ds. And we know how to integrate that, right? That's the sine, that's the cosine plus 3, and you proceed. And 24, the same deal. If I take f of x, y, ds, that is the integral. And again, they gave us the limits from 1/2 to 1. Now f, I will take the I, throw that in for x. Keep everything separate. X in the denominator, that's t cubed. The j is at the top, and ds is something you have to figure out every time. You take r prime of t, and that's going to be 3t squared 4t cubed. And if you find ds, which is the magnitude of this, that would be the radical, or the square root of the 9t to the 4th plus 16t to the 6th. What is that mess? That is the square root of t squared into 9t squared plus 1. That is t the square root of 9t squared plus 1. 9t times square root of 9t squared plus 1 dt. So this is going to become the integral of, let's see how this works, 1/2 to 1. This is t squared over t cubed times t times the square root of 9t squared plus 1 dt. Now these t cubes cancel out, and I'm left with the integral from 1/2 to 1 of the square root of 9t squared plus 1 dt. And I was going to say you integrate, but I have this in my notes, and I notice there's an extra t, and then it hits me. It's actually right there. This is a 4. This is t squared. So this is a 2. This will keep a 1 left. So you use a u sub, and even if it wasn't a u sub, I was going to say, if it wasn't a u sub, you would let 3t equal tan of theta and proceed, but there it is. So again, I'm going to try to set up as many as I can. Hopefully all the evens. I'll try in every section if possible. We'll see. And there's the homework. Again, for now we're doing the mechanics. And in the sections to come, you start seeing the application of this and how everything comes together.